with our 12-13 guide. We're going to get into solving trigonometric equations. Tomorrow will be a test day. Again, I'm not here, so if you need to sign up for a test, make sure you do that, so it's in the folder for you. Thursday, we're going to finish up the guide, and then Friday is a test day. Okay, any questions? Okay, so up until now, we've been determining the exact value of a trigonometric ratio when I give you an angle. So I give you the sine, that's something like pi over 3, and then you look at the special triangles to tell me what that ratio is. Today, what we're going to be doing is trigonometric equations, which is I give you a ratio, and I want you to tell me what angle gives me that ratio. So I want to know the sine of x equal to 1/2. So when is the sine of x equal to 1/2? Okay, because the sine is periodic, so here's the graph of the sine curve, right? And it's periodic, which means it goes off in both directions forever and ever, right? My question here is, when is it equal to 1/2? So it's equal to 1/2 here, it's equal to 1/2 here, it's equal to 1/2 here, it's equal to 1/2 here. And if the program kept drawing it, it would be equal to 1/2 again. How many times is it going to be equal to 1/2, my sine curve? Yep. Yeah, it's an infinite number of times. Okay, so when you're solving trigonometric equations, unless they want the answer in general, they're going to have to give you an interval in which they want your answer. So we're going to solve when is the sine of x equal to 1/2 in the interval between 0 and 2pi. So now, if I look at my graph, I'm just looking at between 0 and 2pi, when is it equal to 1/2? So what value is this, and what value is this? Okay, so in order to solve that, we are going to hope the smartboard works. Okay, in order to solve that, we are going to follow the following process. Step 1, determine whether the ratio is positive or negative. That's pretty easy. You just look over it to see if it's positive or negative. And then once you've determined where it's positive or negative, draw the terminal arms in the correct quadrant. So that's step 1. Okay. So those are the two answers, right? So I'm going to need to draw two set of axes, right? Because I'm trying to determine where the sine is equal to positive 1/2 and sine is positive in 2 quadrants. So what 2 quadrants would my terminal arms be? Because sine is a positive ratio. We're at 2 quadrants for sine positive. 1 and 3. Okay. So I draw my terminal arms in quadrant 1 and in quadrant 2. Once you use the positive and the negative to determine where your terminal arms are, then you're done with the positive and the negative sign. You don't use that ever again. Okay. The second step is to determine the related angle using the special triangle. Okay, so now I want to determine the related angles using the special triangle. So I want to determine the size of this angle in here. Okay. So I draw the special triangles. The first one, 1, 1, root 2, and pi over 4. And the second one, 2, 1, root 3, pi over 6, and pi over 3. So from my special triangles, which angle would give me a sine ratio of 1/2? Okay. Good. Okay, so angle pi over 6, because pi over 6, the opposite side is 1, the hypotenuse is 1/2, so an angle of pi over 6 will give me a sine ratio of 1/2, so that is my related angle. Now the answers to my question, when is the sine of x equal to 1/2, bless you, are the angles in standard position. So I have to figure out this blue angle and this blue angle. Well, the first one's pretty easy because it's already in standard position. So my first answer to my question is pi over 6. How do I get the next blue angle? Six pi over 6, which is pi, right? Yeah, perfect. Okay, so John said, yeah, go all the way over to pi and then subtract off this little bit, and then the remainder will be your angle. Okay, so pi subtract pi over 6, which John said is 6 pi over 6. And that is your other answer. Okay, so if I look at the graph, stretch this out a bit. Here. Okay, so you can see, when is the sine equal to 1/2? Pi over 6, we got that answer. When is it equal to 1/2 again? At 5 pi over 6, we got that answer. Okay. Those two answers are called the primary roots of the equation. Because remember, like I talked about, that answer, this answer right here, is going to repeat itself again over here, and it's going to repeat itself again over here, and it does that forever in the positive direction, and it does that forever in the negative direction. Okay. So the process is going to remain the same on how to solve trigonometric equations. The only difference is the interval in which you're solving. So let's try another one. So let's figure out when the cosine of x is equal to -1 over root 2. But this time, I want my answers to be between -2 pi and 2 pi. Okay, so the process is going to be remaining the same. Determine where your terminal arms are. Come up with your related angle, put your related angle in, figure out your angles in standard position, and those are your two primary answers. Okay, so let's start that. Two quadrants. Cosine is negative in the second quadrant and the third quadrant. I look at my special triangle. The cosine of pi over 4 is 1 over root 2, so my related angle is pi over 4. I put my pi over 4 in. And then the answer to my question are those angles in standard position. So I need to figure out that blue angle and this blue angle. So the first one can be found in much the same way John said last time, taking pi and subtracting off pi over 4. On a common denominator. That's my first answer, my first primary root. And my second primary root, how can I find that one? Okay. Perfect. So pi plus pi over 4, again finding a common denominator. So those are my first primary answers. So now, I graph that. So this is the cosine curve, right there. And I wanted to know when the cosine curve was equal to -1 over root 2. I don't quite know that value, so I'm just going to graph it, a straight line. So, -1. And what that'll do is put a nice line where it's equal to that. So we just found this answer right here, and we found this answer right here. Okay? My question asked, if I go back to my question, it asked when is the cosine of -1 over root 2, when is it equal to that between -2 pi and 2 pi? If that's here, I have to figure out my answers between here and here. So I have to come up with this answer, and I have to come up with this answer. How do you think I can get those? Sure.
So you subtract 2 pi from the increase graph.
Awesome. Why would I do that?
Because you found 0 to 2 pi.
Perfect. That's exactly what it is. Another cycle up. Okay, so this answer right here is going to repeat itself 2 pi away. Okay, and I'll keep doing that forever. Right? This answer right here, my second answer, will repeat itself 2 pi away. So if I want to get to the other answers, I'm going to add on multiples of my period. Does that make sense? Okay, so if I go back up to here, I want the answer on the other side of this. So I take my first primary root, and I subtract off multiples of the period. If I do that, find a common denominator, that'd be 8 pi, so subtracting it would be -5 pi over 4. And if I subtract off another 2 pi, I can keep doing that forever, right? But now I'm outside of my interval, and I don't care about those answers. I only want the answers inside of my interval. That's my first primary root. My second one will give me my other answer, which will be 5 pi over 4. Subtract 2 pi, finding a common denominator. And that's my second answer for my second primary root, which gives me a total of 1, 2, 3, 4 roots to this equation. And we saw that in the graph because we look back at the graph, there's 1, 2, 3, 4. Okay, so let's try this question. So when is the sine of x equal to -√3 over 2? And this is just another way of writing down the interval. So when x is between -3 pi and 4 pi. So in order to solve a trigonometric ratio, draw your two set of axes, because there's always two roots for a ratio. Determine where the terminal arms are using the plus and the minus, and then forget about the plus and the minus. Figure out your related angle, figure out your angle in standard position, then those are your two answers, and then add on multiples of the period in order to get the answers inside of the interval you're looking for. Okay, so now let's just execute what I said. So I'm drawing my two axes, set of axes. My terminal arm, sine is negative in quadrant 3, and sine is negative in quadrant 4, right, because of the cast rule. I look for what angle will give me a sine ratio of √3 over 2. Again, we're forgetting the negative. That's what the terminal arms were. So √3 over 2, it looks like an angle of pi over 3. So this is pi over 3. This is pi over 3. Figure out my answers in standard position. That blue angle there. this blue angle there, and those are my two primary roots. So my first one will be pi plus pi over 3, which is 4 pi over 3. And my second primary root, how would I get my second one? We're going to come across one like this guy. Rebecca? Perfect. Okay, so all the way across is 2 pi, subtracting off that, and I get 5 pi. Okay, any questions with coming up with the two primary roots? Pretty straightforward stuff. Now what you need to do is to answer the question that's being asked. Okay? When is the sine curve equal to negative root 3 over 2 between this interval? So what I would do is I would start with my first answer and I would add on multiples of the period, 2 pi, until I get outside of the interval, and then I would go in the other direction to get all the ones that fit inside the interval.
Excuse you, Mr. Proctor?
Yes?
Hi, is Alan Moreski there, please?
Yes?
Can you come to the office for a second, please?
Yes, you can.
Thank you.
You're welcome. Okay, so now what I'm doing here to get the other answers is I'm taking multiples of 2 pi and adding it to here. Okay, so if I add on 2 pi to here, right, that becomes 10 pi over 3. Finding a common denominator, right? So 2 pi is the same thing as 6 pi over 3. Okay? If I add on another 6 pi over 3, that would be 16 pi over 3, which is way outside of my interval. Okay? So really, if you want to figure out what these are in terms of over 3, 4 pi would be the same thing as 12 pi over 3, and negative 3 pi would be negative 9 pi over 3. So you want your answers to fall in between there. So I'm done with the one going to the right side. Now I'm going to go to the left side. I'm going to start with this guy again, and then I'm going to subtract off 2 pi. And if I subtract off 2 pi, what do I get? Close. Really close. No, no, don't change your numbers. Negative 2 pi, right? Just subtracting, right? So remember, right, what you're doing is you're subtracting multiples of 2 pi. I'm just going to put this in red here. You're adding, let you know what happened. I'll do it in green. You're adding multiples of 2 pi. If you find a common denominator, you're really adding 6 over 3. Add and subtract 6 over 3, right? So if I take this and subtract off that, I'm going to get, and then using this one to get to the next one. If I subtract off another 2 pi, that would give me negative 8 pi over 3. That makes sense what I'm doing? Okay, now if I subtract off again, I'm going to be outside of my interval. So I'm done with getting my answers from my first root. Now I work with my second root. If I add 2 pi to here, if I add 6 pi over 3, I get 11 pi over 3, which fits inside of my interval. If I add another 2 pi, I'm outside of my interval, so I'm done going in the right direction. Let's go in the left direction. If I subtract off here, I would get negative pi over 3. And if I subtract off again, I'd get negative 7 pi over 3. And if I subtract off again, I'm going to be outside of my interval. So there are 1, 2, 3, 4, 5, 6, 7, 8 angles inside of this interval that would give me a sine ratio of negative root 3 over 2. Just want to show you. I go back to the sketch, graph my sine curve. So there's my sine curve. Graph my value, which was negative square root 3 divided by 2. Right there. The top of this is a little better. And it was from negative 3 to 4. So those are my 8 answers right there. 1, 2, 3, 4, 5, 6. Any questions on that? Okay. Next thing. So everything that we've done so far is when the sine or the cosine is equal to a fraction, equal to a ratio. Okay. What if I want you to solve in the interval from 0 to 2 pi, so I just want my answers in the first cycle. When is the sine of x equal to 1? How do you think you'd get that answer? Jordan?
You just look at the graph.
Exactly. Right? Whenever the sine or the cosine is equal to 1, negative 1 is 0, just use what you know about the graph. Here's the sine curve. Here's where it's equal to 1. That value is pi over 2. The answer to your question is pi over 2. Okay? When is the cosine equal to 0? When is the cosine equal to 0? You know your cosine graph, it's equal to 0 here and here, which is pi over 2 and 3 pi over 2. Okay, so whenever it's equal to 1, negative 1 is 0, that's where you use your graph. If it's equal to a fraction ratio, that's where you have to figure out your 2 primary angles by the method I showed you. Okay, going back to question A here, if I extended this from 0 up to, say, 4 pi, when is the next time sine is going to be equal to 1? How would I figure out the next time it's equal to 1 again? Yeah, exactly, add 2 pi, right? Because it's periodic, it's going to be equal to 1 again, 2 pi away. Okay. How about for 0? What would I need to add to 0 to get to my next answer? Pi, exactly. That's the only time you don't add the period when you're dealing with zeros, because your answers are only half a period away. Okay, so whenever you're dealing with zeros, you would add on multiples of pi. Any other one, you add on multiples of 2 pi. Okay, any questions on that? Okay, if you can grab out your calculators, I would appreciate that. So I'll do setting up the next example. Solve in the interval okay. So on this one here, exact same thing. So I want you to solve when is the cosine equal to 1/3. Okay, so it's not 1, negative 1, or 0, so we have to figure out where our primary angles are by first drawing our axes, drawing our terminal arms in the proper location. Cosine is positive in quadrant 1, and cosine is positive in quadrant 4. The next thing you need to do is to determine your related angle. So you get your related angle, you go back to here, it says determine the related angle using the special triangles. What angle would give me a ratio of 1/3? You would say anybody? Sure? None of them. Okay? So I'm going to change this to determine the related angle using the special triangles if you can. If you can't, the only way to do it is using your calculator. Okay, but the process is exactly the same. Okay, so really this is section E, and this is estimating your answers. So you do it the exact same way. So on your calculator, you want to figure out the related angle. So you would hit your your shift or your inverse button, whatever one you would hit, then hit your cosine button, and then go 1 divided by 3 to get your related angle. Depending on how your calculator works. So some people have to go 1 divided by 3, answer, shift cosine. Some people will go shift cosine bracket 1 divided by 3. Figure out how your calculator works. And then somebody tell me what the answer is. Oh, and also too, it has to be in radians, right? Everything's in radians. Tell me what the answer is to 2 decimal places.
1.05.
1.05. Anybody else get 1.05? Anybody get anything different? What did you get, George?
I got 1.23.
1.23. Anybody else get 1.23? Dean, check yours again.
I put mine in radians today for what else.
Yeah, so just check it again. So take 1, divide it by 3, hit equals first, and then hit shift and then cosine.
Okay, yeah.
Okay. So it's the exact same step, right? The only difference is you're getting this answer from your calculator as opposed to your related triangle. Excuse me, your special triangles. David, question? 1.22. So you do everything exactly the same. Now you want to figure out your angle and standard position, this one here and this one here. Okay? So the first one is already in standard position. The second one, again, remember we are approximating it. So instead of subtracting it from 2 pi, you can use 6.28, because that's the approximate value of 2 pi. And if you do that, what do you get as an answer? Okay. So those are my 2 primary roots. I have to answer my question inside of my interval, right? So I need answers, because if I go to the right, if I add multiples of 2 pi, I'm going to be outside of my range, so I need to subtract off intervals now from here. So my second one is going to be my first answer, subtract off 2 pi, which I'm going to estimate as that, and my second one is going to be my first one, subtract off 2 pi. So this answer would be negative 5.05, and this answer here would be negative 1.23. And those are my 4 answers. Okay, so the process is exactly the same as doing it with the exact values. The only difference is you're estimating your related angle and you're estimating your answers. Processes are the same. Okay? One of the most common mistakes people make is so if I ask this question right here, to draw your 2 set of axes, the sine curve is negative in quadrant 3 and in quadrant 4. And this is the mistake people make, is when they go to figure out the related angle using the calculator, they put in the negative sign. Do not put in the negative sign ever. The negative sign tells you where to draw the terminal arms. So to figure out your related angle, you would go 3 divided by 4, hit equals, shift sign, or shift sign, bracket, 3 divided by 4. Either way, do not use the negative sign. Okay, the negative sign tells you to draw it. What is the answer to that? Can we do that for you? What's the size of the related angle? Rebecca? 0.8. So 0.85, 0.85. Figure out your answers in standard position. So the first one is pi, which is the approximate value 3.14. Plus 0.85, and the next one is 2 pi, which the approximate value is 6.28 minus r. So the first one I think you can do because it's pretty easy. What's the next one? .43. So those are your primary roots. Now to get inside the interval, you have to subtract off again multiples of your period, which is 2 pi. And when somebody gets that, you can tell me what that is. And the next one. Thank you. So those are the answers inside of the interval. So with that example, because we've done a lot of them, the only thing I wanted you to remember is the positive and negative of the ratio determines where you draw the terminal arms, then forget about that. Okay, don't ever use that again. And then get your related angle. If it's two sides in the special triangles, use your special triangle. If it's not, you have to use your calculator to estimate. Any questions on that? But the process is the same, whether you're doing the exact values, like this guy here, or you're doing the estimated values. Okay. One last example. Okay. What's the answer to this question? Ha.
Well, I thought it was saying for synchrone.
Sure, sure.
Yeah, so it's negative and then 30 goes up.
Yep. And then?
You apply your gradient.
Yeah. Where do you get that from?
From synchrone.
What do you mean from the terminal arm? Remember, you get the related angle either from the special triangles, these guys, or your calculator. We're going to get this guy from the calculator or the special triangles. Calculator, right? Because the side 3 is in the special triangles. Figure it out on your calculator. What's the answer? Go back up. There is no answer. Why is there no answer to this question? Nick. Pardon? So you're saying it goes up 5? Okay, excellent. That's exactly why there's no answer, right? Because remember, the sine curve looks like this. The highest it ever gets is 1. The lowest it ever gets is -1. This guy's asking me, when is it here? It's never going to touch. There's no answer to that question. So you can't do it. If you ever get one where the range is outside of 1 and -1, just omit that equation. We're going to get equations like that when we work with quadratic ones on Thursday. Okay, so that's all you need to know to be successful in solving trigonometric equations.